In this video, we'll be talking about graphing vertical transformations of the trig functions sine and cosine. So first, let's do a quick review of what the sine and cosine graphs look like. On the left, you'll see a picture of the sine of x, and then on the right, you'll see a graph of the cosine of x. So let's go ahead and fill in the parent tables really fast. And these parent tables beneath are just those key points that we really wanted to make sure that we have graphed as we start sketching graphs of the sine and cosine. So for the sine at 0, it's 0, at pi halves it's 1, pi at 0, 3 pi halves is -1, and 2 pi is 0. For cosine, it's going to cycle through the same numbers, but we're going to start at 1, then go down to 0, go to -1, go to 0, and then get back to 1. So remember that with these graphs, our domain is all real, so from -infinity to infinity, and then our range, or how far up and down we can go, is kind of bounded by how far this graph is up and down. So in these parent functions, it's from -1 to 1. Today we're also going to talk about something called the amplitude and the midline. So let's jump down and see what those would look like. So we have two types of vertical transformations. One is that I can change the amplitude of my graph. So the amplitude is the distance from the midline to the top or the bottom. So if you look at our picture down here, the midline is basically the line that chops the graph in half horizontally. So let me grab, maybe I'll just get a red pen. And with this dotted line, I'm going to sketch in the midline. Okay, so it kind of just chops the graph right in half. The amplitude is how far up and down you can go from the midline. So in this case, the amplitude is 3, because that's how far my highest point is from the midpoint and how far down my lowest point is from the midline. Now you'll see in the equation here that the amplitude is really easy to see. It's just the number that sits in front of the sine or the cosine. And that is always going to be the case. If you look at this general form equation down here, the a that's in front of the sine, or it could be in front of the cosine, is always going to be the amplitude. The only caution to have here is that we always take the absolute value of the amplitude. So say we had like a -3 in front of the equation, we would still say that the amplitude is 3, because it's the distance from the midline to the top or the bottom. The other thing we can do is we can shift the graph up and down vertically. So vertical shift would say how far up the graph has moved up or down. Okay. So if you look at this graph in this picture down here, you have the red graph, which is the original sine function, and then it shifted up 2. And you can see that all these points have just kind of shifted up 2 spots. One thing that you'll see here is a new vocabulary word, which is the midline. So the midline, like we talked about, just chops the graph in half. As you shift the graph up or down, you can just think about however far up and down you shifted it, that's where your midline is. So in this graph that we're looking at right here, the midline is at 2, which means that I shifted this graph up 2. So if I were to write the equation for this, it would be sine of theta plus 2. Okay, I just shifted everything up 2. I'm doing that vertical shift. So again, you'll see in this general form, the a will always be the amplitude, which basically is going to stretch out your graph, right? It's making it either taller or it could also make it shorter. And then you have this plus d, which is always going to be your vertical shift. I also wanted to write this general form of the equation in cosine. The graphs we looked at were both sine graphs. But finding the amplitude and the vertical shift is the same in a cosine graph. So you can use these same principles. So let's do some practice. First, writing equations that have specific amplitudes and vertical shifts. So in this practice, we're going to write an equation for the sine curve that has the following amplitude and vertical shift. So I basically want to take the sine equation and I want to make it so that it has an amplitude of 4. So I'm going to put a 4 in front of the sine, and it has a vertical shift of -2, so I'm going to subtract 2 at the end. Okay, the next one's going to be similar. If the amplitude is 1/3, it'll be 1/3 sine of theta plus 6, because I've shifted it up 6. Okay. All right, let's do a couple examples now of actually graphing this. Okay, so what we're going to do is we're first going to use the equation to identify the midline, the amplitude, and the vertical shift. I'm actually going to start in this first one with the vertical shift, because I see this -2 right here, which tells me that I have shifted my graph down 2. Okay. Which means that my midline is at y equals -2. Okay. And I'm actually going to come down and I am going to, with a solid line, I'm going to draw in the midline. Okay, so this red line is the midline. So when I finish my graph, I should be seeing a, this red line should chop my graph in half. Now the amplitude is the number that's in front of the sine of theta. So it might be tempting to say that the amplitude is 0. It is not. The amplitude is 1 in this case. It's like having a 1 times the sine of theta here. Which means that from my midline, the distance I'm going to go up and down is 1. So with dotted lines, I am going to draw in how far up and down my graph is allowed to go. Since my midline is 2, the highest it can ever get is my midline is -2. So the highest it can ever get is -1, and the lowest it can ever get is -3. So my whole graph should fit in between those 2 red dotted lines. So let's talk about creating a table here. So what I'm going to do with my table is for my theta values, remember these are like my x values, I am going to use increments of pi half. So 0, pi halves, pi, 3 pi halves, and then 2 pi. Okay. And in this shaded in box, I'm going to put the coordinates from my parent function. So you could jump back, and I'm basically going to copy this table down. So in the original equation, y equals the sine of theta, whoops, that should be a positive one. 1, 0, -1, 0. Those would be the coordinates of my graph. Now I have shifted my graph down 2, which means that all of my y values have decreased by 2. So what I'm only going to do is I'm going to subtract 2 from each y value. So instead of being at 0, I'm going to be at -2. Instead of being at 1, I'm going to be at -1, -2, -3, -2. And now what I'm going to do is I am going to graph this top line, which are my x values, and then this bottom line, which is my y values. So think about that middle kind of shaded in line. It's kind of like a stepping stone or a tool to get to your final graph that you need. So I'm going to have a point at 0, -2, at pi halves, -1, at pi 0, 3 pi halves, -3, and then 2 pi, -2. Okay. So I'm going to go ahead and connect these, and I know the basic shape that I'm trying to get. It's going to be a wave. It'll look like that. Now I know that my graph's going to continue to the left and to the right, so I'm actually going to go ahead and plot the left side of this graph. It's going to follow the same pattern. I'm going to have to go up, down, in the same kind of increment. So I'm just going to go ahead and, since I went to the right pi halves to get my first point, I'm going to go to the left pi halves. I'm going to go down, then up, and then back down. Okay. So my graph should look something like this. So notice a couple things that are important is that my whole blue graph, which is my final graph, fit perfectly within those 2 red dotted lines that I said it would, which is important. And I was able to just use my parent graph to get one section of my graph and then just kind of mimic that graph on the left side. Okay, let's do some examples with the cosine. So if I look at this equation in number 2, I have f of theta equals the cosine of theta plus 4. So let's fill in what we know. So first of all, we know that this plus 4 has shifted the graph up 4, which means that my midline is y equals 4. So I'm going to go ahead and draw in my midline again, just so we can keep visualizing where this graph is going to be. And then my amplitude, which is the number in front of my cosine, is just 1. So the distance I can go from my midline up or down is 1. And if you look at the scale of this graph, each of these little tick marks is 1/2, which means that I need to go down 2 tick marks. So my whole graph should fit in these dotted lines. Okay. I really like drawing the dotted lines that make sure that I don't get points that I shouldn't get. As I create the parent table, I'm always going to start with the same theta values. So I'll fill those ones in. And then I'm going to fill in the y values of the parent function of cosine. So again, if you've forgotten those, you can come back up to this parent table that we filled in at the very beginning. So cosine goes from 1 to 0 to -1 to 0 to 1. Now to get my new y value, since I have shifted the graph up 4, I am just going to add 4 to these. So at 1 I'll be at 5, at 0 I'll be at 4, 3, 4, 5. Okay. So let's go ahead and graph, and again I'm just graphing the top row and the bottom row because those are my new values. So at theta equals 0, which again is my x coordinates, my y value is 5. At theta equals pi halves, my value is 4. At pi, my y value is 3. 3 pi halves, I'm at 5. And then 2 pi, I am back up at 5. Okay, so it'll look something like that. Okay, and again, I want to mimic that graph on the left side. So I'm going to kind of think about translating that same graph over on the left side as well. And remember, these graphs, even though we're just drawing a portion of them, they're just going to keep repeating these waves over and over and over and over again. So that is what that graph would look like. On this one, let's actually talk about the range and what the range would be. Just because it's kind of interesting to see how this, how what we've already done makes the range really easy for us to fill in. So the domain, like we said, is always going to be from -infinity to infinity. The range is how far up and down I can go. And I actually have already kind of drawn the range in. Those red dotted lines that we drew in tell us how far up and down my graph can go. So really, I just need to write my range using those two numbers. So the lowest I can go is 3. The highest I can go is 5. So my range would be from 3 to 5. So even though this graph goes on forever and ever to the left and right, it's just going to keep bouncing back and forth between 3 and 5, 3 and 5, 3 and 5, and all the values between it. All right, let's take a look at one where we change the amplitude. So in number 3, I have f of theta is equal to 4 sine of theta. So right away, I'm just going to notice that 4 is the amplitude. And I'm not adding or subtracting anything on at the end, so my vertical shift would be none, and my midline would be y equals 0. So since I haven't moved up or down, that midline is just going to stay where it normally is at y equals 0. So I'm going to go ahead and draw in the midline here. And again, that line should chop my graph exactly in half. And then my amplitude tells me that I can go up 4 from the midline, so I can go up as high as 4. And I can go down 4, so I can go down as far as -4. So this is going to be a fairly tall graph when we start, as we start sketching it. So first, let's go ahead and get our parent function values down. So I'm always going to start with these same theta values. My sine function goes from 0 to 1 to 0 to -1 to 0. And here let's talk about what we're going to do to our y values here. When we shift things up and down, we just add a number to our y value. When we change the amplitude, we multiply by whatever the amplitude is. What I'm going to do is I'm going to multiply all of my y values by 4 because that's the amplitude. And what that is doing is it's basically stretching my graph out vertically. It's going to make it look taller and probably a little bit skinnier. So let's go ahead and graph these points. I have a point at 0, 0, at pi halves 4, at pi 0, 3 pi halves negative 4, and then 2 pi 0. Okay. I'm going to go ahead and try to connect these and make them look wavy. Now remember, you want these to be wavy and not pointy at the ends. So do your best to make sure that those still look like a wave. And I'm going to mimic these same points on the left side of the graph so that I can have 2 iterations of that same wave piece. Usually it's nice to have at least 2. We would call these cycles, so complete cycles of the graph. Okay, so you'll see here that I was able to keep my graph between the red dotted lines that I needed to, and changing the amplitude just stretched this graph out. Let's actually fill in the range for this one as well. So remember, the range is directly related to those dotted red lines that we drew in. So the range is going to go from -4 all the way up to 4. That's the bounds that my graph is going to have. All right, so we've done some examples where we just shifted the graph up and down. We've done some where we changed just the amplitude. Now in number 4, let's change the amplitude and do a vertical shift. So we have f of theta is equal to 2 cosine of theta minus 3. So this 2 in front, that's going to change the amplitude. The minus 3 is going to shift the graph down 3, which means my midline is y equals -3. So I'm going to go ahead and draw in my midline and my dotted lines that tell me how far up and down my graph can go. So my midline's at -3. And then my amplitude is 2, which means I can go up 2 to -1. Or I can go down 2 to -5. Okay. So my whole graph's going to fit within those 2 dotted lines. I just got to figure out what it looks like once it's in there. So let's go ahead and fill in our parent tables first. So what my original cosine would look like. And you're going to get really familiar with these parent graphs of sine and cosine because you're going to use them so much. Now here's an important part. As we start changing our y values to create our new y value down here, you have to account for both the amplitude and the midline. You need to do the amplitude first. So what we're going to do is with each of these y values, we are going to multiply by 2, and then we're going to subtract 3. So you've got to do the amplitude first. So in this first one, if I'm changing 1, I'm going to do 1 times 2, which is 2, and then 2 minus 3, which is -1. So that is my y value here. I'm going to take 0, multiply it by 2, which is just 0, and then subtract 3 to get -3. And then let's write these out. I probably should have written the last one out too. I'm going to do -1 times 2, so that's getting my amplitude. And then I've got to subtract 3 to account for the vertical shift down, so I'll get -5. When I do 0, I'm going to get the same -3 that I got when I transformed the 0 before. And then this 1 is the same as the first one, so I'm going to get -1 again. So remember, amplitude first, then shift. Okay. So I'm going to go ahead and plot these now. I have a point at 0, -1. pi halves -3, pi -5, 3 pi halves -3, and 2 pi -1. This is one case where I really recommend drawing in your midline as well as how far up and down your graph is going to go. Because then as you start plotting these points that you've created from your table, if you get a point that's clear up here, then you know you've done something wrong, because you know that your whole graph has to fit between these two dotted lines. So let's go ahead and sketch this in. Kind of fill in the spaces between these dots. And again, I want to extend this graph over to the left as well, so that I get 2 complete cycles. See if I can connect dots at all today. And that is what my graph will look like. Okay. So as you're working through these, just be really careful that you are paying attention to what the amplitude is, to what the vertical shift is. Another thing to be cautious of is make sure that you're using the right cosine or sine graph to start with. So you really want to make sure you get your equation, and here we are graphing the cosine, so we started with the cosine parent function. You want to make sure you start with the right parent function, or you're going to get something funky.